Okay, guys, this is the Unit 3 in our first lesson, Lesson 3 in our first unit, Graphing Basics Math Review. And what you should see on the screen is a scatter plot graph. Notice that the points are not perfectly linear. However, you do see a positive correlation, meaning as the x-axis increases, so does the y-axis increase, giving you a positive slope. And you can see this in the line that I'm going to draw here. Now let's say this particular graph is showing the relationship between, let's say we're going to make a bridge, okay? And the relationship between the number of toothpicks the bridge is made out of and how much mass it can hold. Well, how do you know which variable goes where on the graph? So there's a mnemonic device called dry mix that's going to help you remember which one goes on the y-axis and which one goes on the x-axis. The D in dry stands for the dependent, also known as the responding variable, goes on the y-axis. So the dependent is it's the thing that the experiment it's the variable that you measure because it depends on something you change in the experiment. So go ahead and write down that the y-axis, the dependent variable, is what you measure. Now, the mix, M stands for manipulated, I stands for independent, goes on the x-axis. So the manipulated or independent variable is what you control, and that goes on the x-axis. So if we go back to the example I gave you, we're making a bridge out of toothpicks, which we actually will do around February, and we're going to load it down with masses until it breaks. And so we're going to measure how much mass can the bridge hold as a function of the number of toothpicks used to create it. So what do we control in that particular experiment? We control the number of toothpicks. So the x-axis is going to show the number of toothpicks used. Okay? So what goes on the y is what we measure. We measure how much mass it can hold. So on the y-axis, we're going to say mass held before break. Okay? And remember, on your y-axis and your x-axis, you have to have units. Am I talking about mass in kilograms, grams, centigrams? What am I talking about? Well, let's say we're going to talk about grams. Okay? So you have to indicate that on the axis. Now, when we properly graph data, you should be able to take your graph and hand it to someone in the hallway that's not even in physics, and they should be able to read the graph, and they should be able to know exactly what it is you're trying to show them. So, again, we need to have our axes labeled properly. Remember, your dependent, also known as responding variable, goes on the y. Your manipulated, also known as independent variable, goes on the x. In addition to that, we have to have units so we know what it is we're talking about. Grams, kilograms, etc. And then finally, we need a title. So we can just call this, toothpick bridge. Usually what you'll do is just choose the title of the lab. Okay? Next, we're going to talk about a slope calculation. Be ready to practice this on Tuesday. Alright guys, now we're going to look at the slope calculation formula. Most of you remember from, late elementary and middle school that the slope of a line is equal to the rise over the run. Okay, but what does that mean? Rise. What axis rises? The y-axis. What axis runs, that's horizontal, is the x-axis. So we can actually rewrite the formula slope equals the change in y, and there's our Greek letter delta, looks just like a triangle, over the change in x. Alright? Now, we need to actually be able to rewrite this in even more specific format. And here's how we can calculate the change in. So I'm going to pick 2 points. Okay, I'm going to pick this point right here. I'm shading in green. That's going to be point 1. And this point right here, I'm shading in green. That's going to be point 2. Alright? So, to get change in y, we're going to need to take y2 minus y1 divided by x2, which is the run, minus x1. And this is the formula, what you see in green. I know it's sloppy, but what you see in green is the formula that I need you to use in this class. Now, before we can use this particular formula, we need to actually write down the coordinates for point 1 and point 2. When we write our coordinates, we're going to take the x value, which is 2 for point 1, and the y value, which is 4 for point 1. And then we're going to do the same thing for point 2. X goes first, which is a 5, and going across 8 is the y. Okay, I just wrote in and labeled for each coordinate the x1, the y1, the x2, and the y2. And that's going to help make sure that I don't put the wrong number, the wrong number in the spot that I need. So let's get the slope of this line between point 1 and point 2. Okay? So y2 is actually going to be this 8 minus y1, which is going to be this 4, divided by x1, which is 5, minus, 5 was x2, excuse me, it's late, and x1 is 2. So again, x2 is 5 and x1 is 2. So the slope equals 8 minus 4 is 4 divided by 5 minus 2 is 3. And when you run that through your calculator, you should get 1.3, and the 3 is repeating, so we can just put a bar over it. I will talk to you later about the units that will need to be included with this number, but for right now, just make sure you are okay with calculating slope between 2 points. Alright, this is our last example of this particular lesson. Here you can actually see that we have a scatter plot graph, which means we have dots that seem to be going in the same direction. Notice that the slope is positive because it's moving upwards from left to right. So we have a positive slope. Alright, and the point of this particular part of the lesson is to reacquaint you with the equation for a line. Y equals mx plus b. And the picture that I have here is actually pretty good. The m is going to be your slope, which we already learned how to calculate. The b, you can see it right here, is going to be your y-intercept. You really need to understand the significance of the y-intercept when you're doing a lab where you have to graph data. You know, what does the y-intercept mean? The y-intercept means what is y equal to when x is 0. Again, I'm helping you out for the Barbie lab if you're paying attention. The y-intercept means what is y equal to when x is 0? And I'll talk about that more a little bit later. So again, the m is the slope, the b is the y-intercept. That can be gotten off the graph, no problem. The x is you basically pick a point on the line. And what I like to do, when you draw a linear regression line, you do not, and I repeat, you do not connect the dots, as you see in the picture. You take your ruler and you try to draw a line that seems to be in the middle of all your points. The same number of points above as you have below. So we can see in the picture I have basically 2 points on the line. I have 2 points above and 2 points below. This is a good linear regression line. And then to calculate the equation, the slope I can get using the slope formula. The y-intercept I can get by reading the graph where the line crosses the y-axis. The x-coordinate and the y-coordinate come from the point where the linear regression line intersects the most. And in my evaluation, I think it'd be right here. So if I were trying to get the x, I would look straight down, and whatever the value is right here, I would write down for the x, and then I would look straight across, and whatever the value is right here, I would write down for the y. And usually what will happen is you will calculate the slope, you will get the y-intercept from the graph, and then you will be able to get either the x or the y. Okay? We're going to talk a little bit more about this next week. Hope you have a great weekend, and please be ready to do work on this topic on Tuesday. Have a great weekend.